All right. Hi, everyone. Thanks for joining today. We are really happy with how this webinar series has been going. Today is the last webinar in the series. We have low-tech process-based restoration design and construction considerations with Jen. And we're super excited for the presentation. So I'll just do a quick intro and then I will hand it off to Jen. Oops. So first, the BC Wildlife Federation is a provincial organization, and we work and live across what is known as British Columbia. And I'd like to acknowledge that the BCWF, we acknowledge and respect the 203 First Nations who have lived in relationship with and steward these lands since time immemorial and continue to do so today. At the BCWF, we acknowledge that reconciliation takes time, and we are prioritizing building relationships with the First Nations communities. And we support Indigenous-led conservation by partnering with First Nations on habitat restoration, education and training, and knowledge sharing opportunities. And we're really excited to support and work alongside the many nations and bands, and are grateful to have the guidance from elders, knowledge keepers, and community members throughout our work. And today I'm calling in from the unceded and traditional territories of the Coquitlam First Nations. And if you know whose territory you are currently on, please include it in the chat box now, as I know we have people joining from many different locations today. So if you don't know whose land you're on, I encourage you to make yourself familiar with the Indigenous peoples whose land you occupy. And this map here is from Native Lands, the website. So it's a great website to get information on the different lands throughout our province. I'd also like to thank our sponsors. This webinar is free and open to the public, and we're able to do that because of the sponsors that support us in the work that we do. So for those of you who I'm sure there's varying levels of knowledge of the BC Wildlife Federation here today, and maybe if some of you have attended past webinars, you've heard me talk about the BCWF. This program is offered through the Wetlands Education Program. The Wetlands Education Program runs a number of different workshops and restoration projects, both virtual and online throughout the province. We have the Wetlands Institute, Map Our Marches, Wetlands Keepers, which are listed here on the slide. And then we have the Wetlands Workforce that runs a number of different restoration pods throughout the province. And if you'd like to know more about the BC Wildlife Federation and our other departments, you can check out our website at bcwf.bc.ca. So today on Zoom, please use the chat box for all questions. We'll hold questions till the end of the presentation when we'll have time for discussion and questions. And please keep yourself muted to avoid background noise. Yeah, thank you. Myself and Kendall will be here to help in the chat box if you need any tech support or have any questions throughout the webinar. Great, so thanks so much, everybody. I will hand it over to Jen now.
Awesome. Thank you, Emma. Hi, everyone. Let me just get all set up here. Okay, everyone can see my screen?
Yes.
Yep, looks good.
Okay. Well, hi, everyone. Thanks for joining us today. My name is Jen, and I'm calling from the traditional and unceded territories of the Musqueam, Squamish, Tsleil-Waututh, and Coquitlam First Nations. And I'm the Beaver Restoration Assessment Lead with the BC Wildlife Federation. So a big part of my job is to connect with organizations and communities that are interested in low-tech process-based restoration work, specifically in beaver-based restoration, and support the planning, implementation, and monitoring of these projects. And before I started with the BC Wildlife Federation, I did my master's degree in ecological restoration, and my research was centered around beaver-based restoration work. And so that's really how I got my start in this line of work. Before we dive in, I just wanted to talk quickly about the BC Wildlife Federation and what our role is in this emerging low-tech process-based restoration world. So we are a nonprofit conservation organization, and we have a lot of experience in the protection, restoration, and promotion of wetlands. And so we have an initiative that's called the 10,000 Wetland Project. And this is a term that was coined by Monica Pearson from the province. And the goal of this initiative is to help increase the density of small wetlands and wetland complexes to help improve watershed resiliency and really enhance nature's ability to adapt and recover from disturbances like floods, droughts, and fires. And so the idea is to do this by using low-tech process-based restoration techniques, including beaver dam analogues and post-assisted log structures, which we'll be talking about more today. And to do this, we're really looking at addressing 4 key aspects. The first is looking at policy. So low-tech process-based restoration is very new in BC, and it really falls within this legislative gray area. So we're trying to examine and address obstacles to low-tech process-based restoration work within the current legislation. The next piece is science. So we're working with experienced groups to develop effectiveness monitoring protocols and help address some key research questions to help improve the practice and applicability of low-tech process-based restoration in BC. We're also focused on collaboration. So we're really trying to facilitate a network of practitioners that are either interested or already engaged in this type of restoration to provide access to resources, advice, and just a platform to support each other's projects and to share knowledge. And lastly, of course, is implementation. And so we connect with and provide support to project partners across the province to really get boots on the ground and advance this practice. And so the more groups that are working on this type of work, the better. And so here's an overview of the presentation today. I'll be going over some of the basics of low-tech process-based restoration, also known as LTPBR, and the key principles. And then I'll be talking about low-tech process-based restoration techniques, mainly beaver dam analogues and post-assisted log structures, and the different types of structures and their functions. And then we'll be looking at some key design considerations for these structures and what kind of materials you will need to actually implement these projects. So first, let's just start with the basics of what is low-tech process-based restoration. And so this is a method to address structurally starved riverscapes. And so when we say riverscapes, we're referring to the channel and the floodplain habitats, and all of that connected makes up the riverscapes. And these structurally starved riverscapes are primarily systems that lack functioning beaver dams and woody accumulations. And so often this lack of structure is a direct cause of degradation and can also be a result of land use changes. And so the lack of structure has really led to a decrease in water residence time, floodplain disconnection, and more simplified and homogeneous habitats. And so by reintroducing and mimicking some of these natural structures, we're initiating, promoting, or enhancing these fluvial and geomorphic processes that have been degraded and creating more resilient stream systems. And so that's kind of where the process-based comes from. The low-tech stems from the fact that these structures are small in scale and can be hand-built using natural materials. Even though the structures themselves may be small scale, they are constructed in higher densities, and they really function together to help improve large-scale ecosystem processes. These structures are meant to be temporary, like those natural features that they mimic. And another really big benefit to this type of restoration technique is that it's really nudging the system onto a recovery trajectory and then allowing natural ecosystem dynamics to drive the restoration. So because of this, it's really able to scale up to the level of degradation that our watersheds are facing. And so there are a few key principles that low-tech process-based restoration follows. The first is that streams need space. And so healthy and functioning streams are dynamic and they shift their position in the valley bottom over time. And to effectively restore functioning systems, there needs to be sufficient space and understanding that streams need to use this space to allow streams to move and reconfigure within their valley bottoms. And so the valley bottom is usually what defines the lateral extent of what we refer to as a riverscape. The next principle is that structure forces complexity and builds resilience. So beaver dams and woody debris alter flow patterns, and create more physically diverse habitats. And so this improves biodiversity, which then creates more resilience to disturbances compared to simplified and homogeneous habitats. And so this diagram really shows how a beaver dam influences hydraulic processes with changes to the speed, direction, and depth of water. And so this in turn impacts those geomorphic processes like erosion, deposition, and the transport of sediment. And this all leads to a more diverse and complex habitat units, which are then able to provide niches for various organisms to help increase biodiversity. Third principle is the inefficient conveyance of water is healthy. And so we really do want spongier landscapes that are able to capture peak flows and reduce those potentially damaging floods, and then slowly release that water to supplement base flows. And so the best way to get more diverse water residence time is by increasing structure within the system. And so this graphic shows how without beaver dams, flood events are mainly confined within the channel. And so that results in bank erosion, scouring, and a loss of soil because water is rushed through this confined system. But once there is some structure in the form of beaver dams here, the water is spread out across the floodplain, and the volume and velocity of the water that's associated with a flood event is dissipated and spread throughout the floodplain. And so this is a different approach to restoration, and I like to think of it as kind of a paradigm shift to a more nature-based solution. Traditional restoration techniques like channel reconfiguration and engineered log jams are really highly designed, and they require engineered drawings and heavy machinery for implementation most of the time. And so while this is applicable in some settings, it's quite expensive and it can really limit the scope and broad scale applicability of restoration. And so these approaches also tend to focus a lot on channel form and stability rather than those processes that help create and maintain healthy systems. And so what often ends up happening is that type of restoration can lock streams into place, making them static. And then when natural ecosystem dynamics take place, like a beaver moves into a project site or a high flow event changes the channel form, this can be seen as a failure because it's deviating away from that designed intent. But with low-tech process-based restoration, typically projects do not require site-specific engineered designs, and construction can be done with hand tools, though sometimes you can use heavy equipment as well. So because of this, single projects can actually cover kilometers of stream reach for a fraction of the cost and can help address degradation at a lot larger spatial scales. It can even expand beyond the working area if beavers establish and expand throughout the watershed, or if woody accumulation is naturally promoted by the structures. And so this is seen as a more dynamic approach to a dynamic system that focuses on self-sustaining recovery from degradation. And so one of the structural elements in low-tech process-based restoration are beaver dam analogues. And so these are channel spanning structures that are designed to mimic the form and function of natural beaver dams. And so they can be constructed using handheld machinery and locally available vegetation. They're typically constructed in high densities, and a group of them working together forms what we call a complex. There are a few different types of BDAs, which we'll go into in a moment, but in general, there's no golden method to their design and construction. The methods that you will use very much depend on the site conditions, like the material you have available on site, the site access, the flow regime, which we'll also be touching on more later. So the first type of BDA we'll talk about is called the post-line wicker weave. And this was the first iteration of a beaver dam analog. And so these involve the driving untreated wood posts into the stream bed and then tightly weaving branches, usually willow, through these posts. And you're alternating that weaving direction kind of like a basket. And then sediment is used to patch any gaps in this weave. There have been improvements to this design over the years. And so because this first iteration was really built like a vertical wall with one line of posts, there wasn't that much structural stability with that one line of posts. So sometimes the BDAs would swing open like a gate during high flow events. And this wall-like structure also meant that there was no protection on the downstream base of the structure, so that when water flows over top of the BDA, the force of that water dropping can form a scour pool at the base of the BDA, and that cuts into the stream bed that's actually holding your posts upright. And then that can lead to structural failure, as you can see in this image. And so to address this, there have been some improvements that have been made to the design. So you can add a second line of posts for more structural stability. It doesn't have to be used for all structures, but in systems that have a higher stream power, it's good to have that additional stability. And then there's the addition of a downstream mattress. And so this is branches that are integrated into the weave and placed parallel to the flow on the downstream side of the structure. And the function of this is to dissipate flow energy when it overflows due over top of the dam and prevent that scouring at the base. And this is also just something that beavers naturally incorporate into their dams when they build in the wild. And so these improvements kind of evolved into what we now call a post-assisted beaver dam analog. And this tends to be the most widely adapted BDA in the restoration community. But there are also BDAs that are built without posts, and these are called postless BDAs. And so the creators of the BDAs actually prefer postless structures because it better reflects how beavers build their dams naturally. And so these postless BDAs, however, are most appropriate in those stream systems that are already capable of supporting beaver dams. And basically how these structures are built is in 15 to 30 centimeter layers that are called lifts. And the first lift is created by laying out and packing the first layer of material. So that's mud, sediment, branches, cobbles that you have available on site. And you really want to make sure that you're building a strong base. And so the width of the base will really depend on what your overall end dam height is. But in general, you want to have a 2-to-1 vertical to horizontal base. And so when you complete the first layer, you should see a backwater forming upstream of the structure if the stream is wetted during the time of construction. Then you'll continue to build in these lifts or these 15 to 30 centimeter increments, ensuring those layers are ponding water as you go, and also kind of incorporating that downstream mattress as you build. And the final step is just building to the crest elevation, so the maximum height of your dam. And you want to make sure that the top of the dam is even, or else you might get flow concentrated to one spot, and that can result in some weak spots in the dam. So water should be ponding upstream of the dam once it's complete. And a final option, if you're worried about stream power during high flows, is adding posts to reinforce the dam. You would want to drive these posts deep into the stream bed to provide more stability, and it's good to aim to have about 1/3 of your post length embedded into the stream. Here are just some photos of different types of BDAs in action. We have a post-line wicker weave, post-assisted BDA, and a postless BDA. And so those are some different ways to construct beaver dam analogs, but there's also different types of BDAs. So primary BDAs are used to create ponds that are capable of sustaining an underwater entrance to a lodge or a bank den. And so these are typically around 1 meter deep. They create ponds that are 1 meter deep. And so something to think about as well is if you live in a colder region or are doing a project in a colder region, these ponds should be deep enough to prevent freezing solid during those winter months. In general, the primary BDAs should be in locations where the structure is capable of creating kind of a laterally extensive deep water habitat. So it's good to look at floodplain access. In this photo here, you can't really see it, but the floodplain access should be on the right side or the left side of the screen to create that primary pond. Secondary BDAs are used to expand ponded areas upstream and downstream of the primary dam. And so they expand the inundated areas. And this can increase safe access to forage for beavers if you want to, if you anticipate beavers will be at the site or relocating beavers to the site. But secondary BDAs can also be used downstream of primary BDAs to help dissipate the stream gradient. And so they do this by raising the water level and almost creating like steps in the stream. So there's not as steep of a difference in water height. And these steps decrease what's referred to as the hydraulic drop. And so the hydraulic drop is the distance between the crest of the dam or the top of the dam and the downstream water level. And so because of this, secondary BDAs can also be used to help address fish passage concerns as they can reduce that required jump height and provide a deeper pool that actually helps fish jump. And another tool that's in the low-tech process-based restoration toolbox is post-assisted log structures, or PALs. And these are designed to mimic and promote the process of wood accumulation. So like BDAs, they're constructed with locally sourced woody material and untreated wood posts. And this large woody material is placed in the stream bed or on the floodplain and then wedged into place by pounding these posts at an angle. And you want to make sure you're pounding the posts at an angle. If you have them vertical, then the woody material might just float up and over your structure during high flows. But unlike beaver dam analogues, PALs don't require fill material, and they typically consist of larger wood than what's used in beaver dam analogues. And so they can be channel spanning, bank attached, or mid-channel structures that we'll talk about soon. And the design and orientation of PALs within the stream will really depend on what your project objectives are. And so channel spanning PALs are similar to beaver dam analogues in that they extend from bank to bank. They help slow water velocity, and at some times they can hold back water. However, PALs don't need a uniform crest elevation like beaver dam analogues, and they're much more porous as there's minimal fill material. These PALs can often be used to widen the channel if there are erodible banks and if you're in an incised system. There are also bank-attached PALs, and these can be used to promote hydraulic diversity. So they create these fast convergent flows that's towards the opposite bank, and they can also create some backwater eddies upstream and downstream of the structure. And these types of PALs can really have different effects depending on what the composition is of the opposite bank. And so if you have a resistant feature on the opposite side of the stream bank, like bedrock, roots, or wood, it can create a constriction jet as water is forced to flow through this narrow point. And so usually if you want to form a good constriction jet, you would want your structure to be 80 to 95% of the bank full width of the stream. Then if you have an opposite bank composed of erodible material, the PALs really promote lateral widening of the channel because that flow that's directed to the opposite side then cuts into the bank. And this can also be useful to accelerate the recovery of incised streams. There are also mid-channel PALs, and as their name suggests, they're installed in the middle of the channel, and they can be used to split flow around the structure. And so this promotes diverse flow conditions and creates an eddy downstream of the structure. It can also promote mid-channel bar development or in plain bed systems or on riffles. And these types of PALs are often very effective when built in close proximity to each other. Here are just some photos of some PALs in action. Different types of PALs. We have bank attached, channel spanning, and mid-channel. So these techniques can really be used in a variety of settings and to meet a variety of project objectives. And so here are some typical restoration objectives and their recovery trajectory. We won't go through them all, but they include incision recovery, floodplain reconnection, enhancing in-stream complexity, enhancing flood, fire, and drought resilience and recovery, as well as increasing local beaver populations. We will talk about the recovery trajectory for incision recovery, though. And so incised streams often form from land use changes and are really prevalent in systems that have heavy cattle use, because cattle walk in and around the streams, they cause erosion, they suppress vegetation establishment. And so these systems become disconnected from their floodplains, and the channel is often confined within an incision trench. And so during high flow events, there's nowhere for that water to go besides in the channel. And that leads to further erosion and soil loss as the stream cuts deeper and deeper into the incision trench. And without access to the floodplain, there's no overbank flows, and the water table is very low. But when we introduce structure into the stream, so in this diagram, it's beaver dam analogues, but PALs can also be used. This slows the velocity of water that's rushing through that incision trench and leads to channel widening around the structure. And so with wider channels, inset floodplains start to develop that can help with flow dispersion. And so the structures there can also be structures downstream that are used to capture some of that sediment that's eroded with the channel widening, and that can help build up the stream bed and work towards floodplain reconnection. And so over time, with the maintenance of structures, either by beavers or by humans, the stream can reconnect back with its floodplain, raising the water table and creating more diverse and complex aquatic and riparian habitat. And so these are just some examples of project successes with incision recovery. Excuse me. So this was a project done by the Bureau of Land Management in the States. And this just involved beaver relocation. So once they got naturally built beaver dams back in the system, it really helped to increase that lateral expansion of the channel and help promote vegetation establishment and floodplain reconnection. Similarly, this is a project by the Methau Beaver Project, and this used a combination of beaver dam analogues as well as beaver relocation to address channel incision. And so to help meet project goals, additional restoration actions can be done in conjunction with these types of structures, and this can include riparian planting, beaver relocation, and cattle exclusion fencing. And so the appropriateness and effectiveness of these structures will really depend on your site and what the cause of degradation is. Beaver relocation is often done in conjunction with projects that incorporate BDAs, as beavers can maintain, improve, and expand upon the structures. So in terms of site planning and design, it's very highly field-based and very dependent on what your restoration objectives are. But here, these are just some general guidelines. So you really want to have a high density of structures. By having more structures, this reduces the importance that's placed on any individual structure and focuses the attention on the complex and the system as a whole, which is the overarching goal of low-tech process-based restoration. You also want to have a variety of structure types as well to maximize that hydraulic diversity. And so primary and secondary beaver dam analogues promote that upstream pond at base flow, and they create slow-moving deep water habitat, whereas PALs can be used to create areas of shallow and fast-moving water. And so the locations of where you want to place these in the stream is also very highly dependent on the site. But with BDAs, you often want to look for signs of historic dams in the stream reach. Even if there's not an obvious and intact dam, you can often see beaver chews that are lodged in the banks at old dam sites. Other things to look for are pinch points and anchor points that you can build your beaver dam analog off of. And it's also really good just to think about where the water will go, looking at your upstream inundation area and seeing where the best opportunities are to form pools or to activate relic flow paths. With PALs, it's good to look for areas where woody debris is or should be accumulating naturally, and what the bank composition is. So if you want to widen the channel, you want an erodible opposite bank. If you want to force a constriction jet, you want that non-erodible bank. And also just thinking about what type of habitat units you want to create. And so here are just a bit more specific considerations when designing beaver dam analogs. And so first, it's important to think about the flow regime. If you have a flashy system or a system with a high peak flow, that can lead to less dam stability. And so if you are building in a flashier system, it might be flashy because it's degraded and you're doing this project to help address that state of degradation. It's really good to incorporate posts for those added support. And so you probably want at least 2, maybe 3 lines of posts to help reinforce that structural stability. It's also good to think about stream power. So stream power is a function of gradient and discharge. So sites that have a higher gradient and higher discharge have more force exerted on the structure, and that can potentially reduce the stability. Stream power can be dissipated by dispersing flows onto the floodplains. So another key consideration is thinking about floodplain access. Can the structures promote flows onto the floodplain and reduce that force that's exerted on the dams? And sometimes, like with incised channels, you might not have floodplain access, and your restoration is functioning to widen the channel and to create that inset floodplain to disperse flows. And so another consideration is stream substrate. So sandy stream beds are highly mobile and they're more susceptible to scour around the structure. But another consideration is if you have very rocky stream substrate, then it can be more difficult to pound the posts into the stream bed. With channel width, wider channels just require more building material and more time to construct them. So that's often why we want to look for those pinch points within your system. Also looking at gradient. So as we talked about earlier, gradient is related to stream power. Higher gradient is higher stream power, but it's also related to the pond extent. So if you have a steeper channel, you would have to build your beaver dam analog to a higher crest elevation to create a larger pond. And another thing to consider is bank height. So this determines how deep your pond would be. So taller banks means deeper ponds, but there's also limited flow dispersion, so they could be more prone to structural failure. Projects that involve beaver relocation, there are also some kind of key elements to consider to increase the likelihood of relocation success. The first is vegetation. So there needs to be enough forage and construction material available at the site. And so the quality of forage material is usually determined by the type and density of vegetation, as well as how close is it to the water course. Beavers also need cover. And so this can be in the form of deep water habitat. So that's the ponds that are formed by primary BDAs. And they should be at least 1 meter deep to provide sufficient protection from predators. You can also construct a temporary lodge that's right alongside the water's edge so that there is some immediate cover right after the beavers are released and some form of protection from predators. And finally, the number of beavers released can also impact relocation success. And so when relocating a lone beaver, they'll often disperse and try to find a mate. So studies have found that if you release an opposite sex pair or a family unit, it increases the likelihood of beavers staying at your project site. But the Methow Beaver Project has developed a scorecard to assess the suitability of sites for beaver release. So I'd really suggest taking a look at that if you are planning to incorporate that into your projects. And so now with kind of all these design considerations in mind, what do you actually need to implement the projects? And so first you need some kind of instrument to drive in the posts. There are a lot of options, but what's generally recommended is a hydraulic post pounder. You can also use a handheld post pounder, but this is not recommended for sites that have a high density of structures or with coarser stream substrates, as that's a lot of work. Another option is to use heavy machinery, like using an excavator or a backhoe, but this would be more expensive, require better site access, and might have more of a footprint left on your site. The next element is the posts. And so the main requirement with the posts is that they're untreated wooden posts. But the specifics like diameter and length can really vary. Keep in mind, if you are doing the post pounding yourselves, you don't want them to be too long, or else it'll be really hard to drive the posts into the stream bed because you're holding the machinery over your head. And these posts can be sourced from just your local post and rail or a local timber supplier. Ideally, they'll be pointed at one end, but you can always manually point them with a chainsaw, though this takes a lot of time and you have to have comfortability operating a chainsaw. And then other equipment is just anything to cut wood and vegetation at the site. And so this can also really vary, but generally loppers, chainsaw, pole saw can be really helpful. And so these are construction materials that can be sourced on site. And so for PALs, this would be small logs and branches. The dimensions are not too important. For BDAs, this would be branches, limbs, and brushy fill, as well as fill material like cobble, soil, and leaves to pack into the structure. This can really be tailored to the conditions of your site. In some cases, like if you have a recently burned area, there may not be enough vegetation on site, and you may have to source materials from elsewhere. That's okay as well. It just has to be incorporated into your planning process. And so there are a lot of really great resources that are free and publicly available for low-tech process-based restoration projects. Most of the information from this presentation is from the low-tech process-based restoration design manual. And this goes into a lot more specifics. So if folks want to learn more about it, I highly recommend using that resource. The Beaver Restoration Guidebook also, they just released an updated version last year, and they go a lot into depth on the use of beavers and beaver dam analogs to help restore stream systems. There's also a ton of webinars available online. I would highly recommend the Riverscapes Consortium YouTube page. They have workshops that kind of go through the chapters of the low-tech process-based restoration design manual. So it's a really nice way to kind of walk through the manual. There's also a beaver-related restoration training series that's hosted by the National Association of Wetland Managers, as well as the Bureau of Land Management, that I have found was really great. But those are just to name a few. There's lots of information out there. If people are interested, I really encourage you to look more into it if you'd like to do this type of work. But that is all I have for now. So I will open the floor to questions.
Great,
Yeah.
thanks, Jen. I have one in the chat here. Have you had any conflict/issues with the BC dam regulations when creating beaver dam analogs?
Yeah, that's a good question. Dam safety has been brought up, like in in our conversations with permitters. Technically speaking, dam safety has to be involved if any of your structures are storing more than 10,000 cubic meters of water. That's a lot of water, and none of our structures are really holding back that much, but it is an important piece of consideration to include dam safety in our conversations with regulators about how we're going to permit these projects, and making sure that we find a permitting path that everyone is comfortable with. So dam safety has been involved in the conversations. The main requirement, though, is that you're not succeeding that 10,000 cubic meters in any pond.
Great, thanks. There's also one more question. You touched on this, I think already you pretty much answered the question, but has there been any work to translocate beavers? For example, urban beavers that have little to no free habitat to disperse locally to a beaverless system that would benefit from their presence. So I don't know if you want to talk a little bit more about our efforts there.
Yeah, that's a really great question. I think first is, instead of going straight to relocation, is trying to focus on coexistence techniques first. This is because if you remove beaver, even if you're translocating it to this beautiful habitat that you just created for itself, the chances of another beaver moving into that site that you just removed a beaver from are very high. So trying to make sure that you're working on coexistence techniques as a first step, instead of getting into this endless cycle of trap and relocate, seeing what the conflict is and how that might be addressed. So can you install a pond leveler to reduce that conflict? Can you do some tree wrapping to reduce that conflict? For some sites, though, there's just no there's not a lot of wiggle room to allow beavers to do their thing, do their dam building thing. And so in those cases, you can trap and release beavers at project sites. There was a beaver, her name was Maggie, and she was released to a project site in Merritt for a beaver dam analog project that was done with the Nicola Valley Institute of Technology and the New-Ih Indian Band. And those beavers did stay at the release site, and they did maintain and improve upon those BDAs. So there are success stories, but there's you just want to make sure that you're taking the steps necessary to ensure that you're going through, can we actually live with this beaver where it currently is? As that's the best way to kind of make sure that you have a self-sustaining system.
Great, thank you. We have some more. Can you see the chat, or do you want me to read them to you? I don't know what works better for you. Sometimes it's hard to see the chat.
I have the chat open, yes. Are we? I think there's a question here on, can you outline how have you outlined BDAs and PALS projects in in-stream work applications to the province, which reduce the need for an engineered design drawing? That's also a really good question. And so the permitting process around BDAs in BC is still in the process of becoming determined. Most projects can fall under a Section 11 change approval. Some specific projects, depending on land ownership, the amount of water stored, may trigger a water license. In terms of tips to include in your application, there is a conceptual design, a conceptual engineered design that was created for that project that I was referring to in Merritt, created by Golder Associates. It is available online, and we have been including that within our appendix for these applications, and then also including specifics on our site design, inundation areas, potential water storage volumes, and then just giving kind of a strong background of what these structures are, the science that has been done on them already. There's a lot of studies that have been done, primarily based out of the States, that have showed how effective they are in certain stream systems, primarily in the West. And so just making sure that you have everything kind of clearly outlined and showing that there is a conceptual engineered design that has been made, but the specifics for a project typically don't require a project-specific engineered design. Okay, the next question has been, BC Wildlife has been reluctant to issue permits for beaver translocation. Has this changed? That's a good question. It's the main hesitation, from my understanding, with the reluctancy to issue those translocation permits is they don't want to release the beavers to areas where they're going to cause more conflicts. So by having a specific site in mind where you've created suitable habitat for them, and it would actually be helping to restore that habitat as well, I think that could help make the issuing of the permits a lot simpler. That being said, the permit that was required for that site in Merritt, as long as you are able to show that you have a suitable release site and you're following those guidelines, then the regulators are fairly open, from my understanding. Okay, next question. Okay. Marissa said her question was more in concern for dispersing urban juvenile beavers that have no free habitat to disperse locally after they leave their family. I see. So when coexistence isn't isn't much of a they just have nowhere to go. That's a good point. I think it might be harder to identify those individuals, but beavers do kind of expand quite rapidly. They have larger litter sizes, and so once a beaver colony is established, the young, once they're 2 years old, they do need to disperse, and so there's no specific guidelines for it, but I think that could be integrated into kind of like a project design framework, as long as you kind of are able to show that they have no habitat to disperse into. Okay, Tracy asked, have there been any studies on the longevity of BDAs? You mentioned they're meant to be temporary structures. Do we know the average lifespan might be, and are there any concerns that if they fail, the system could revert back to its pre-construction state? Another really good question. The stated design lifespan of a beaver dam analog in the low-tech process-based restoration manual is 1 year. It's designed to withstand a typical flow event, but the structures themselves typically last much longer than that. It's just to set kind of realistic expectations. Also, if you have a lot of structures that are working together within a complex, then that also extends the lifespan of a structure. Typically, the practitioners in the States have stated 5 to 7 years has been like a typical lifespan of a structure that they have found across their project sites. And the point to, if there are any concerns that if they fail, the system could revert back to its pre-construction state, I think there is, to some extent, they are expected to fail, or over the course of the design life, they are expected to kind of devolve and contribute to in-stream complexity. So even if, say you have a beaver dam analog that's no longer ponding water, it's still causing some hydraulic diversity, even if it's not, even if it's breached in some areas. And so it's still contributing to in-stream complexity, and it's still contributing to some of those processes. Beaver dams and large woody debris are just ephemeral kind of in nature. And so that's okay that these structures are also ephemeral in nature. But it is important to kind of state these expectations upfront with landowners, with stakeholders, with permitters, as you're developing the projects. Okay, I think that's all the questions I see. Did I miss any?
Nope, those are all the ones I saw too.
Okay, perfect.
Great. Thank you so much, Jen. This was great. And thanks everybody for coming. This was really great. We really enjoyed hosting this webinar series, and we're grateful for everybody's participation and attendance. We hope you have a great rest of your day. And oh, also, we have just posted a lot of some positions we're hiring for and some new internships up for the summer on the BCWF website. So you can check those out. And we also will be posting all the recordings to our YouTube account. So great. Thanks, everyone. Have a great day.
Everyone.